Today's video will focus on solving polynomials and multiplicity. So far, we've been simplifying polynomials and factoring polynomials, but we haven't actually found any solutions. So when we solve, that just means that there's going to be an equal sign, and we're going to find those, like I said, solutions or roots or x-intercepts on the graph. And the way we would factor a polynomial function is we need to break it down and factor all the way until we get it down to a quadratic function, because quadratic functions are what we are comfortable factoring. Starting with example 1, I need to bring this polynomial with a degree of 5 down to a quadratic function. The first thing that you should always be doing is checking for a greatest common factor. Looking at all three terms, I see that they are all divisible by 3, and also I can pull out an x cubed. Your GCF doesn't magically disappear, remember. We must write it out front, and in parentheses we need to write what remains, so x squared plus 6x plus 9. So we actually already have gotten it down to a quadratic function just by pulling out a greatest common factor. Looking at this quadratic function, since an a is 1, I'm just going to use the guess and check method. Using the factors of 9, I need to get to that middle term of a positive 6. The factors of 9 are 1 and 9, 3 and 3. So using same signs, I would need to put plus 3 and plus 3 to get a positive 6. Meaning our factored form will look like this. Now, because this is a degree of 5 for our original polynomial function, there are going to be 5 zeros, or they're also called roots or x-intercepts on your graphs. Looking at our factored form, we're going to set each equal to 0. So you set the GCF equal to 0. You'll set the x plus 3 equal to 0 and the x plus 3 equal to 0. Because this is x cubed, we actually have a 0 of 0 3 times. 1, 2, 3. X plus 3 being set equal to 0 would give me negative 3, and once again x plus 3 equals 0 gives me a negative 3. So I have 1, 2, 3, 4, 5 zeros, but when I actually look at the graph, we're only going to see 2 x-intercepts. One of them will be at 0, the other at negative 3. Take a look at example 2. Before I can try and factor, I need to make sure that the polynomial function is set equal to 0, so we should do the opposite and add 36 to each side, giving me x to the 4th power minus 13x squared plus 36 equals 0. Once again, our goal should be to factor it down to a quadratic, and when I see a trinomial like this, where I have x to the 4th power and then my middle term is x squared, I can actually treat it like something like this, where we just factor using guess and check. Only instead of having parentheses, x here and x here, x times x gives me x squared. I really want x squared times x squared to give me x to the 4th power. That's really the only difference. Listing out the factors of 36, I want to know what would give me negative 13. So 36 I know is 1 and 36, 2 and 18, 3 and 12, 4, 9, 6, 6. So looking at these, I could use a negative 4 and a negative 9 to give me a negative 13. So negative 4 and a negative 9. We now have 2 quadratics, which is perfectly fine because we know how to solve quadratic functions. Now when I'm looking at these, I notice that both of them are difference of two squares. Remember, if I have something squared minus something squared, I can rewrite it as something like this. Okay, so it's x being squared to get x squared, and then 2 being squared to get 4. So I just need to put my plus and minus now. Once again, I have a difference of two squares. X squared will give me x squared, and 3 squared would give me 9. I need a plus, I need a minus. Because this is a degree of 4, I know that I need 4 zeros. And to get those zeros, or roots or x-intercepts, remember we just set each thing equal to 0. So x plus 2 equals to 0 would give me a negative 2. X minus 2 equals 0 would give me a positive 2. X plus 3 equals 0 gives me a negative 3, and x minus 3 equal to 0 would give me a positive 3. I'd like for you to try A and B and hit play when you are ready. For A, the first thing you should have done is pulled out a GCF, and once you've done that, we would get x squared minus 5x minus 6. This is a quadratic function, which we should know how to factor. Because A is 1, I just use guess and check. The factors of negative 6, so I need to use different signs. That could give me a negative 5 would be a negative 6 and a positive 1. I do want you to write out all of the zeros. So because this is a degree of 6, I should see 6 zeros here. Since it's x to the 4th power, I put 4 zeros. X minus 6 equal to 0 would give me a positive 6. X plus 1 equal to 0 would give me a negative 6. Even though there are 6 zeros or solutions, you are really only going to see 3 x-intercepts. But again, I do want you to write out all of the possible zeros. Take a look at part B. The first thing you should have done is add the 50 to each side since it was not set equal to 0 yet. Once you do that, you see that you get 4 terms. When we factor something with 4 terms, you've learned how to factor by grouping. It doesn't always work, which you're going to see later, but for now, I'm giving you problems that will work. When I factor by grouping, I look at the first 2 terms and the last 2 terms. The first 2 had a GCF of x squared. The last 2 had a GCF of negative 25. You have to pull out that negative because we want these to be exactly the same in parentheses. That way we can pull it out to get the x minus 2. And then in the second parentheses, we write the coefficient. So the x squared and the minus 25. This is a quadratic that we can factor because it is a difference of 2 squares. So x plus 5 and x minus 5. It's cubed, so I know there's 3 zeros. Setting each equal to 0, I got 2, negative 5, and positive 5. So now we're going to talk about something called multiplicity, and this is the reason why I was having you write all of the possible zeros. This is actually the polynomial we had in example 1, so I'm just going to say C example 1 here. For example 1, we determined that we had 5 zeros, because it was to the 5th power, but we had 0 3 times and negative 3 twice. So I'm going to write that here. The zeros were 0 3 times and negative 3 twice. So if I were to ask you about the multiplicity, we would say that 0 has a multiplicity of, and the amount of times that we see it here, so 3. And the negative 3 would have a multiplicity of 2 because it's written twice. So really, multiplicity is when a solution appears more than once. It's a multiple root. And the amount of times it's included, so the multiplicity, does impact the graph. And the way it impacts it is that if it's an even multiplicity, it's just going to touch the x-axis. So my -3, it would just touch the x-axis. If it's an odd multiplicity, other than 1, it would bend as it crosses the x-axis, but whether it's 1, 3, 5, whatever, as long as it's an odd multiplicity, it will always pass through. And that's what I want you to know. It's going to pass through the x-axis. But again, if the multiplicity is something larger than 1, so 3, 5, so on and so forth, it will also bend. We saw this when we had a cubic function, how it had that elongated S shape. It crossed the x-axis but bent as it approached it. Take a look at the graph over here. Now this is actually the graph of the equation. Notice how my x-intercepts are -3 and 0. And because the -3 had a multiplicity of 2, we can see that it touches the x-axis and goes back down. And then as it goes to our 0 of 0, it does pass through. But you can see where it's bending a little bit, where it slows down, crosses, and slowly goes back up. That's because it had a multiplicity of 3, so something that was greater than 1. It's really important we understand, though, you cannot always determine the multiplicity of something just by being given the graph. You can determine the simplest or the lowest degree, but we cannot know for sure what it is. The factored form would be better. We are now going to combine everything we talked about on page 1 into each problem. Example 3, we have this equation here. The first thing I want to do is solve it by factoring. Because I see 1, 2, 3, 4 terms, I'm going to go ahead and try factoring by grouping. So factoring by grouping, I look at the first 2 terms and the last 2 terms. The first 2 terms have a GCF of x squared, so that would become x squared times x minus 1. Now here, I can see that there's a GCF of 25. Now notice how if I only pulled out a 25, I would have a -x plus 1. That doesn't match this exactly, so I have to pull out that negative as well. When I pull out a -25, I have a positive x and a -1. Now it matches exactly, which means I can pull the x minus 1 out front. And then in parentheses, I would write the coefficients, so x squared minus 25. By doing this, I now have a quadratic that I could factor further. It's a difference of 2 squares, so it's x minus 1 times x plus 5 times x minus 5. Since this was a cubic function, I know that there should be 3 zeros, 1, -5, and +5. And again, I just got those by setting each binomial equal to 0. So we're actually going to use Desmos just to check our work and sketch the graph. Desmos is a great app. Otherwise, if you don't want to download the app, it is a free website that you can utilize. All right, guys, so I plugged it into Desmos, and we can see that I do have the x-intercepts of -5, +1, and +5. So checking my work, it does work out. It's kind of hard to see the shape of the graph. So let's zoom out. And then let's draw a rough sketch on our sheets. All right, so if I draw the rough sketch, it looks something like this. And I wanted to point out that the multiplicity here for each of the x-intercepts was 1, meaning that it passed through each intercept on our graph, which we do see. Please make note of the multiplicity and what it means for the graph, and then watch part 2.